Hello and welcome to another very special episode of 52 Weeks, 52 Scientists. Today we are going to be covering Rosalind L.Z. Franklin, the double helix icon born July 25th, 1920 and dead 16th April 1958. Known for the discovery of the double helix, she comes just a week after Women's Day. She was an English chemist and X-ray crystallographer. I will explain what is an X-ray crystallographer in just a moment. But she worked with the fields of chemistry and X-ray crystallography, as it is known. So let's get into her work. So she did work with DNA and RNA. Now, you want to know the full form? Well, she did work with deoxyribonucleic acid and ribonucleic acid. If you notice, the difference is deoxy is added at the start of DNA, and she did work with viruses. Yes, those viruses. Her main work on that is based on the tobacco mosaic virus or tobacco virus. Yes, they basically made a short form of that name. I'm not complaining though. Well, she also worked with coal and graphite. This was mostly in her time at the BCURA, or British Coal Utilization and Research Association. Her work on coal and viruses was greatly appreciated during her lifetime. She got a lot of recognition for the work she did there. However, her work on other fields, most notably the field that we know, her work on coal and viruses was greatly appreciated, as I just said. But in other fields, she wasn't as appreciated. One example of that being DNA. Her work on DNA was mostly underappreciated and not known for centuries and centuries. Not centuries, decades, actually. Anyways, she was that henceforth that's therefore not really well known. That all changed when a modern resurgence happened, and she has been represented as a wronged heroine, the Dark Lady of DNA, a forgotten heroine, a feminist icon, and the Sylvia Plath of molecular biology. That's some pretty cool titles to have. But let's talk about her education. So, as a 21-year-old, she graduated with a degree in natural science from the Newnham College in Cambridge University in Cambridge, England. Here, she studied natural sciences, i.e., science. It's basically equivalent to a BSc in our modern times. She then got a doctorate in philosophy or PhD in physical chemistry from the University of Cambridge under Ronald George Wrayford Norrish, who was the 1920 chair of physical chemistry. But Ronald George Wrayford Norrish was a very unenthusiastic man, and she would later get her PhD in 1945, but not before she worked as a research assistant during World War II at the British Coal Utilization and Research Association, known informally as BCURA. This organization existed from 1938 until 2015, when it was finally dissolved. The last laboratories of this organization closed in the 70s. Then she worked as a chercheur or postdoctoral research fellow at the Laboratoire Centrale des Services Chimiques Lettres, and she was supervised by Jacques Marie. She worked as a X-ray crystallographer. So, I did promise I will tell you what X-ray crystallography exactly is. So, let's talk about that. It's the experimental science that determines the atomic and molecular structure of a crystal. Here, a crystal is beamed by incident X-rays to diffract into many specific directions. Then you measure the angles and intensities of these diffracted beams and draw conclusions from there. It's actually pretty cool. She then worked as a research associate at King's College London. Now, King's College London is a very famous public university. At King's College London, she worked with Maurice Wilkins, and here she also worked with Raymond Gosling. But she did have problems at this college, which we will discuss in a few moments. She had two disagreements that we will get to in just a moment, but she discovered the key properties of DNA, and that is her big achievement. The key properties of DNA is something by which I mean the things that make DNA what it is. DNA, as we know, is the, you could say, the elixir of life. It's the foundation of all living things. So to understand its key properties is a big thing. But you thought that's what she just did? No, there was another cap, feather on her cap. That was the discovery of the double helix. So, working with her assistant Raymond Gosling, they discovered the double helix, which is the shape the in which the DNA is formed. You can look at the shape. I mean, it's everywhere across this video. You might probably have memorized how it looks only by looking at this video, but basically she discovered exactly how these strings of DNA look. She had irreconcilable differences with the director of the King's College, that's John Randall, and her colleague Dr. Maurice Wilkins. Dr. Maurice Wilkins would eventually steal her idea and win a Nobel Prize, but we will get to that in a short minute. But just to note, she didn't have the best of relations with either the director or her senior colleague, and that's why she left King's College, and she left it for Birkbeck College in the University of London, where she researched on viruses under John Desmond Bernal. Now, this was a noticeably better place in terms of how she researched, and she enthusiastically worked on viruses at this place. Enthusiastically, yes. And her work at Birkbeck was her final place of work. Now, I was talking about this DNA thing, if you might recall, in a few minutes ago, and this is what she did. So this photo, you can see, this thing is called photo 51, and it shows the X-ray diffraction patterns of DNA, and this was taken by Raymond Gosling at the King's College in London. Basically, it shows DNA of gel fibers, and this is described as one of the most beautiful scientific photos to be ever taken. Okay, so I was talking about how the colleague she fought with betrayed her. Well, this is what happened. So in the year 1962, the Nobel Prize in Physiology or Medicine was conferred to three guys: Francis Crick, Maurice Wilkins, and James Watson, who's still alive, by the way. Now, these three dudes, they claimed they discovered the fact that a double helix was the shape of DNA. Although they all knew that they were basically plagiarizing their discovery, quote unquote, from Franklin. And Watson said, we should credit Miss Franklin for her discovery. And then there was Maurice Wilkins. Well, would you know what? Maurice Wilkins said that she did not want to give credit. Even though there was no rule against posthumous nominations, it did not accept but James Watson was to nominate her. Anyways, she also developed a model for the tobacco mosaic virus. As I said, it was a 2-meter model of this virus made by none other than Miss Franklin. Now, I won't get into much detail, but she was to present this at an international fair in Brussels the day before her death in London. So she was to fly to Brussels, but she died. And it was a very sad moment for science. Okay, but before she died, there's another person who took her legacy forward and actually gave credit. Her associate Alan Klug, a Lithuanian-born scientist who got the 1982 Nobel Prize in Chemistry. So he won the 1982 Nobel Prize in Chemistry. So what did he actually do? Adam Clark. He developed the crystallographic electron and developed crystallographic electron microscopy and the structure elucidation of biologically important nucleic acid protein. She meanwhile died of ovarian cancer on April 16, 1958 at a tender young age of 37. Just 37. It was a sad tragedy for all of science, and she could not even present her final discovery to the world. So, what did you think of this episode? Tell us below in the comments. Make sure to like and subscribe, and I'll meet you in the next one.